Welcome to Operations with Sets. This should be a relatively quick video, and then you have I'm going to leave a little bit of the work to do for you on this. So, if you have this page in your notes, please take it out and we will discuss some of the vocabulary and what we mean by operations with sets. Okay, if you look at the first vocabulary word, union, the union of two sets is the set of all elements in the given sets represented by that kind of like a U. So we're joining the sets together, and fortunately this one looks like a U, so it's kind of like a happy face. And it's happy because he kind of lets anybody in his club. Okay, if you're part of A or you're part of B, you can join my club, A Union B. So you will notice that we only list the members once. We don't list them more than once, and we do list them in order if possible. But elements of either set can join this set of a union. The intersection is the set of elements that are common to both sets. And the symbol is the frowny face. Okay, because he's a little crabby and he's saying, nope, can't join unless you're in both. You have to be in both A and B to be part of the intersection. Sorry. Okay, so if you look, 10 is a member of both A and B. 20 is not in B, so he's out. 30, not in B, he's out. 5's not in A, and 15's not in A. So the only element that is common to both A and B would be in the intersection. So it's pretty straightforward. For each of the following sets, A and B are given. Find the union and the intersection. So A union B, we're going to start off with our curly brackets, is any element that is in either of them. So 2 happens to be in both. Do I have a 3? Yes, I have a 3. Do I have a 4? Yes, 4 is in both. Do I have a 5? Yep, there's a 5. 6 is common to both. 7, there is no 7, but I do have an 8, and then I have a 10. And that is going to be my union. The intersection, however, is only going to be the elements that are in both. So as I said, 2 is in both, so that's going to be in the intersection. 4 is in both, that's going to be in the intersection. And 6 is in both, that's going to be in the intersection. The other elements are not common to both. So I'm going to let you guys take care of B and C there, and we're going to go down and do some of this vocabulary. Equal sets. Equal sets have the same elements, exactly the same elements. And that's going to be what you would think it would be, which is set A equals set B. Equivalent sets are sets that have the same number of elements. And the notation for that is the little tilde. Now, if you remember, we use this little tilde for a lot of things. So you got to be careful. Again, this is that context conversation. Okay, so A would be equivalent to B. I can have apples, bananas, and cherries, and I can have dolls, toy trucks, and army men. And those are equivalent sets. They have nothing to do with one another, but they each have 3 elements. And then the cardinality is going to be the number of elements in the set. So in the previous example, it would have been 3. Disjoint sets have no common elements. And if you think about the intersection of disjoint sets, you will get the null set. Since they have nothing in common, elements that are common to both would be none. Kind of logical. So we can write that as, if you wanted to write it symbolically, A intersection B equals the empty set. Oh, that was supposed to be a slash. I don't know why my pen just disappeared. Okay. Moving on. The examples on the back just kind of ask you to apply some of this learning to different situations. So if you look at the first example, example A, what we're supposed to do is graph and then write each of the intersection and the union separately in step builder notation. A is all numbers greater than -2, it looks like, and B is numbers between 0 and 7, including 0, excluding 7. So A union B is going to be, we're going to start at the -2, and we're going to just continue up. It's basically going to be set A, because it already contains set B. The intersection is basically going to be set B, because I can't include anything that's not in both, and these happen to be in both. If I write that using set builder notation, I need some curly brackets, and I say that X is an element of the reals such that X is greater than or equal to -2. Make sense? So think about what you would write for B. X is an element of the reals such that X is between 0, including 0, and less than 7, excluding 7. So I will let you do B. And I will also let you do 1 and 2. I'm so kind that I let you do those. And I think that's it for this. So that's all. Finish up those few problems. There's a couple on the front and a couple on the back. And I will see you tomorrow. Have a wonderful evening.